All right, exams are just around the corner, so let's do a super fast review of the entire research journey. We're going to cram everything we need to know from that first little spark of an idea all the way to the final published work. So let's just dive right in. Pretty much everything in science kicks off with a simple question, right? But how do you actually get from that little spark of curiosity to a real, genuine discovery? Well, that journey, that whole structured process, is exactly what we're about to map out. So here's our game plan. Think of it like a 5-stage roadmap. We're going to start with that initial spark, then move to building the blueprint for your study. After that, it's all about the fieldwork, then the big reveal, analyzing the evidence, and finally, we'll wrap it up with the crucial foundation of trust and integrity that holds the whole thing together. All right, so let's kick things off at square one, the spark. What is research really? Because let's be honest, it's not just about typing stuff into Google. It's a disciplined, super systematic process, and getting that down is the first big step. Okay, look at this definition. The most important word here, disciplined. Research is a systematic investigation. And, it's not just for scientists in white lab coats. Think about it. When an engineer is testing new materials for a bridge or a historian is cross-referencing ancient texts, they are absolutely doing research. The whole point is to add something new to what we all collectively know. Okay, this is a big one. This slide breaks down the two main reasons why we do research in the first place. Are you basically on a quest for fundamental truth, developing theories just for the sake of knowing? That's pure research. Or are you trying to fix a real-world problem, like right now, on a construction site? That's applied research. It really boils down to asking, is it true versus does it work? And it's not just about the why, it's also about the how. We've got two main ways to tackle it. First, there's quantitative research. This is where you start with a theory, you get a bunch of numbers, and you test a very specific hypothesis. It's all about measurement. But then you have qualitative research, which is more like an exploration. You dive deep into something to get a real understanding, and the theories actually pop up from all that rich, detailed data you collect.
All right, let's move on to stage 2, the blueprint. You wouldn't build a house without a plan, right? Same thing with research. You absolutely need a solid plan before you even think about starting. This is where you lay all the groundwork for a successful study.
And this whole design process, it's like a set of dominoes. First, you do an initial search of the literature to see what's already out there. Then, you pull all that together to build your framework. From there, you can come up with a clear, testable hypothesis. And here's the key. This is super important. You plan your analysis before you collect a single piece of data. That way, you know you're gathering exactly what you need. Okay, the hypothesis. This is the heart of pretty much any quantitative study. Think of it like your project's North Star. It's what guides everything. And it's not just some wild guess. It's a really precise, educated prediction about how your variables are connected. Basically, if I do X, I think Y is going to happen. But not just any old statement works. A good hypothesis has to play by 3 non-negotiable rules. 1, it has to be testable. You've got to be able to prove it right or wrong with actual data. 2, it has to be a positive statement about what is, not what you think should be. No opinions allowed. And 3, it has to be crystal clear. No fuzzy language. Ambiguity will absolutely sink your research. All right, blueprint's done. Now it's time to get our hands dirty. Welcome to stage 3, the fieldwork. This is where we stop planning and start doing. We're picking our tools and heading out into the world to actually gather the evidence. So there are a bunch of ways to do this, and each one has its own strengths. The best way to think about these research styles is like different toolkits for different jobs. Are you jumping in to actively solve a problem? That's action research. Are you embedding yourself in a group to observe them? That's ethnographic. Need data from a whole lot of people? You're doing a survey. A super deep dive on one single thing? That's a case study. And if you're in a lab controlling variables, well, that's experimental research. So you obviously can't survey every single person in a population, right? That's where sampling comes in. The whole goal is to pick a smaller group that's like a perfect miniature version of the big group. With random sampling, it's like drawing names out of a hat. Everyone has an equal chance. With non-random methods, you're a bit more strategic. You might pick people based on specific criteria to make sure your sample has the right mix. Okay, so you've got your sample group. Now what? How do you actually get the info from them? Well, you've got a lot of options. You can use questionnaires, do interviews, conduct super in-depth case studies, dig through old records and archives, or just plain old observation. Honestly, the best research often mixes and matches these to get the clearest possible picture. And this, my friends, brings us to the exciting part, stage 4, the discovery. You've done all the work, you've got these piles of data, numbers, transcripts, notes, so now what? This is the analysis stage. This is where you transform all that raw info into something that actually means something. When you're dealing with numbers, you're probably going to be using statistical tests, and they basically come in two main flavors. You've got parametric tests, like a t-test or ANOVA. These are really powerful, but they have one big rule. Your data has to fit a nice, neat pattern, usually that classic bell curve. If your data's a little messier or doesn't fit that pattern, no problem. You just use the more flexible, non-parametric tests. They're distribution-free. Now, let's talk about two really common tools, correlation and regression. They're fantastic for seeing if two things are related. But, and listen up, because this is almost guaranteed to be on the exam, correlation does not prove causation. I'll say it again. Just because two things happen at the same time does not mean one caused the other. These tests can show you a link, but they can't prove why that link exists. That takes a whole lot more work. So what happens when you want to compare the average scores of, say, 3 or 4 different groups? You could run a bunch of separate tests, but every time you do that, your risk of making a mistake goes up. The smarter way? Use ANOVA. It stands for Analysis of Variance, and it lets you compare all the groups at once. It's way more powerful and a lot more reliable. And that brings us to our last and maybe most important stage, the foundation. This is all about what makes our research trustworthy. It's what ensures our findings are not only accurate, but that we got them in a way that's ethical and responsible. Okay, validity. This is everything. It basically answers the question, are your conclusions actually true? And we check that against 4 pillars. First, construct validity. Are you really measuring the thing you think you're measuring? Second, internal validity. Was it your experiment that caused the result, or did something else sneak in and mess things up? Third, statistical inference validity. Does what you found in your little sample group actually apply to the entire population? And finally, external validity. Will your findings still work out in the real world outside of your specific study? Look, it's not enough for research to be true. It also has to be good. It has to be ethical, especially when you're working with people. The Belmont Report is our guide here, and it gives us 3 core principles. First is respect for persons. That means you have to get informed consent. People have to know what they're signing up for. Second is beneficence. You have to weigh the risks and benefits. The goal is to maximize the good and do no harm. And finally, justice. You have to be fair about who you select for your study. And the last piece of the integrity puzzle is giving credit where credit is due. This quote here says it all, and it's pretty blunt. If you don't cite your sources, everyone assumes the work is yours. And if it's not, that's plagiarism. It's intellectual theft, plain and simple. It's one of the worst things you can do in academics. So the rule is easy. Always, always cite your sources. So there you have it. That's the whole journey, from a simple question all the way to a finished project that's built on a foundation of integrity. See? Research isn't some black magic. It's a systematic process, a disciplined hunt for knowledge. So the only real question left is, what are you going to discover? Now go ace that exam.